So hi, I'm Pat Reiff of Rice University. And for those of you who weren't able to see my SEEK presentation last Friday, I'm doing a redo of it here with my class. And so you can watch it now. and at the end, I want you to take the Kahoot quiz so I can see how much you've learned and how much you knew ahead of time. And I will warn you, there's at least one question that I don't cover. So that's my way of telling how much you knew ahead of time. All right. Cough, cough. Does it say recording? Yes, it's recording. So I call this talk Texas Nexus because Texas is uniquely situated at the crossroads of two eclipses coming up in the next year. The first one is an annular eclipse that is going to be crossing the United States from the Pacific Northwest through Albuquerque and through Texas, ending up in Corpus and going down into Central America. That's October 14th of 2023, which is a Saturday. So no excuse not to pile in a car and go. 6 months later, there will be a total solar eclipse that will first have landfall in Mazatlan, go across Mexico, across Texas, catch a little bit of Oklahoma, a little bit of Arkansas, and goes up through New England. That is a Monday. And realizing that some of you may be in class and not being able to take your kids outside, we want to give you some information. So hopefully you can convince your principals to allow you and your class to observe one or both of those, because everyone in the continental United States will see at least a partial solar eclipse for one or both of these. But the favored ones who will see an annular eclipse are in the orange band, and the favored ones that will see totality are in the green band. So those are the important places to be. Okay, so this is kind of a primer on what are eclipses and who will be able to see it and what is it and where do I need to go and what do I need to do. So my favorite place, my new favorite place to see whether there's going to be an eclipse in your locality is timeanddate.com/eclipse. And when you go to that website, you put in your town and it will tell you the upcoming eclipses that will be visible from your location. So for Houston, for example, we have the annular and the total that I mentioned. There's a partial lunar eclipse and there's a total lunar eclipse. So all of these are visible. And when you go to timeanddate.com, it'll actually show you the particulars of your timing, what the maximum will look like from your location. So it's a very, very handy piece of software that's completely free and very, very useful. Another good way to find out the particulars where you are is a website called xjubier.free.fr. And for each separate eclipse, it gives an eclipse path, and you can click on any locations. It's a Google map, so you can drill down to your very own backyard and find out exact timing. It will be in universal time, not in local time. So you do have to be able to do that calculation between your local daylight savings or your local standard time and universal time. Plus, it does cost him every time someone loads his map. So if you use his map, please donate. But it's extremely useful, and you can really drill down and literally to your backyard. There are many other websites that are now available. Some of them you even, there's a book that gives you the roadmap of the April 8th eclipse. And so this one's from greatamericaneclipse.com, but there are other maps available, and they're very, very helpful. One key thing to do, though, is be careful about being near the edges, because some of them assume a spherical moon. So I wouldn't trust being really close to the edges. You might miss it. But that's always true to stay in the middle 2/3, because that's where you're going to get the longest eclipses. Okay, so with some of my NASA outreach money, I've created some animations here that help you learn the difference between solar eclipses and lunar eclipses. Now, these were developed to be put on a dome where you can really see the three-dimensional geometry, but we also have flat screen versions, which you are welcome to use. So a solar eclipse is the moon casting its shadow on the Earth. A lunar eclipse is the Earth casting its shadow on the moon. And totality means the entire sun will be blocked out by the moon, which allows us to see the corona. Only during totality is it safe to view with naked eyes. So the t-shirt that I've seen and I'd like to make is one that has a picture of sun, moon, Earth, solar eclipse, sun, Earth, moon, lunar eclipse, moon, sun, Earth, apocalypse. Yeah. In fact, the sun can't fit between the moon and the Earth. But do you know that all the planets can? You can actually touch every planet from the Earth's surface to the lunar surface, and they'll all fit. The sun is only about 4 times too big. So there you go. All right, so here are some diagrams. And again, all these diagrams you may download and use. Virtually all the diagrams that are in books are not to scale. And this isn't to scale either, but it's attempting to be a little closer. In fact, if you did it to scale, the Earth and moon would be too small to fit on a piece of paper more than a pinpoint. And so here is the darkest part of the Earth's shadow is called the umbra, and the outer part is called the penumbra. So when the moon is in the umbra, it's fully eclipsed. If it's in the penumbra, it's partially eclipsed. And this is a wonderful image that was a composite taken of the most recent lunar eclipse, where he took the moon's images and overlaid them. And you can really see the shadow of the Earth in real size. So when we tell you that the Earth is 4 times the diameter of the moon, you know, this is how we knew. And this is how the ancients knew. They saw that curvature of the Earth's shadow on the moon and figured out, A, that the Earth is round, and B, that it's bigger than the moon. All right. Now, if you're very lucky and a lunar eclipse occurs at dawn or dusk, then you'll be in a situation where you look at this red sun in one direction and 180 degrees away, you look at the red moon, okay? Now, actually, technically, you can't see them both at once, but if you're on a tall building, there is some refraction in the Earth's atmosphere, just about one moon's width worth. So technically, you can see, maybe not at the same instant, but within a few minutes of each other, the red sun and the red moon. And the interesting thing of it is, it's that red light from the sun that comes through the Earth's atmosphere here, okay? The blue light is scattered away, so we see the sun as being red, and what's left is the red light that hits the moon. So it is the exact same red light. It's not similar. It is the exact same red light that's painting the moon as going over your head, which I think is really cool. Here's an image that I took of a dawn selenian, and here's the eclipse moon just coming out of eclipse, and you can see the dawn breaking and creating the red clouds above it. So it's that same red light is making the clouds red and the moon red, and it's passing over our heads, which is kind of fun. Okay, so the next total lunar eclipse for us will be the night of March 13th through 14th of 2025. And just everybody in the greater United States will see it, which is kind of fun. All right. So let's move on to solar eclipses. And as I mentioned, the solar eclipse happens when the shadow of the moon falls on the Earth, because the moon's much smaller, the umbra is smaller and shorter, and so it just barely reaches the Earth. And so the path of that umbra across the face of the Earth is where totality will be seen. And everybody who's not in the umbra, who's in the penumbra, they will see a partial eclipse, okay? So the totality is only if you're in the umbra. If you're in the penumbra, then it's a partial eclipse. Now, on average, the moon is not quite big enough to cover the sun. But because the moon's orbit around the Earth is elliptical, and because the Earth's orbit around the sun is elliptical, on average, their angular size, as seen from Earth, are about the same, okay? But if we are exceptionally close to the sun, so it looks bigger, or if the moon is exceptionally far away from us, so it looks smaller, then even when they're perfectly aligned, the moon just can't quite cover the sun. And what's left is a ring of light, and that's called an annular eclipse, because annulus means ring. And so here is the umbra. The umbra doesn't quite reach the Earth. What you get instead is called an antumbra, which is anti-umbra, okay? But there still also is penumbra on either side. Now, annular eclipses are really cool. And really the only safe way to see an annular eclipse with your naked eye is if it's right at sunrise and sunset. This was actually a little bit too soon, so it was a little too overexposed. I was not looking at this with my naked eye, just my camera was looking at it. Here's another example of a little later in the evening. So this is really the only time it's safe to watch a partial or an annular eclipse with your naked eyes, is if it happens right at sunset. The rest of the time, you have to use eye protection in the partial or the annular. Only the two can you get by without using eye protection, okay? Both of these eclipses, however, the ones coming up, are going to be closer to solar noon. So this is never going to be true for these two eclipses, all right? So for these two eclipses, you've got to have eye protection or projection techniques for all except the 3 to 4 minutes of totality. Okay, so this is a video that I've made on solar eclipse versus lunar eclipse geometry. And there are previews of them at this website, and you can download all of them here in flat screen.
When the new moon passes exactly in front of the sun, its shadow crosses the Earth. The deepest part of the shadow is called the umbra. People in the umbra see a total solar eclipse. It takes about an hour for the shadow to cross the Earth. 2 weeks later, the full moon can cross into Earth's umbra. Since the Earth is 4 times the diameter of the moon, the umbra is also 4 times larger, or 16 times the area. So, lunar eclipses are more common than solar eclipses. Everyone on the night side of Earth can see a total lunar eclipse, but only people in the narrow strip of totality can see a total solar eclipse. So, not only are lunar eclipses more common, more people can observe each one.
This is now a similar movie, but now talking about annular. An annular eclipse happens when the moon is farther from Earth than usual. The deepest part of the shadow is called the umbra. Only if you are in the umbra can you see a total solar eclipse. Since the umbra doesn't reach the Earth, no one can see totality. And so it is not safe to view a partial or annular eclipse without eye protection. Since the moon doesn't cover the entire sun, a ring of sunlight remains. It is called annular eclipse because annulus means ring. This animation shows the view of an annular eclipse as seen through a safe solar filter. Sunspots may be visible on the sun's surface. The moon moves in between the Earth and the sun. At the maximum eclipse, the sun is not completely covered. And so it is never safe to view an annular eclipse directly. Always use eye protection. This animation shows the view of an annular eclipse as might be seen through a handheld solar filter. Sunspots may be visible on the solar surface. Clouds may pass in front of the sun, and a ring rainbow may appear. At the maximum eclipse, the sun is not completely covered. So you must always use eye protection during an annular eclipse. Okay, so if you're in the center of the path of the annularity, then that ring will be nice and symmetric. But if you're off to one side of the ring of the path of annularity, then at its maximum, it'll be skinny on one side and fat on the other side. Okay. So if you want the prettiest annulus, you want to be on the center line. Okay. All right. So now we are going to stop and take a little Kahoots quiz. So now let's talk about a phase of the eclipse. First contact is when the disk of the moon first starts to cover the sun. During the partial phases, you must use solar filters or projection techniques to safely observe the sun. It takes about an hour for the moon to completely cover the sun. The last bit of the sun is the diamond ring. Second contact, totality. Third contact, put back on your filters. The last hour, the moon gracefully exits, uncovering the sun. As the last bit of the moon leaves the sun, it is fourth contact and the end of the eclipse. So that is first contact, second contact, third contact, and fourth contact. So totalities between second and third. All right, now this diagram shows some of the things that you'll see during totality. Only during totality will you be able to see the corona, and that's why it's so important. 99% is not good enough, so that's takeaway number one. 99% is not good enough. It will be 94% in Houston, but I want everybody to do that 3.5-hour drive, which will turn into a 6-hour drive, or maybe an 8-hour drive to get to totality. Because this is one of the most incredible things you'll ever see. So the corona is this light scattering off electrons that are trapped on the sun's magnetic field. So in the polar regions of the sun, where the magnetic field just goes out into space, you can see them as straight lines, but more close to the sun's equator, the magnetic fields make loops and they trap the particles. And the really bright part of the loops close to the surface are called prominences, and they're red. You'll also see the chromosphere, which is also red. And then these parts of the corona that goes out into space are called helmet streamers because they kind of go out and come back in. So they're called streamers, are the extensions. Now, this view is very similar to how it will look to you if you've got a good pair of binoculars on. If you're just looking with your naked eye, you won't see this much detail. And that's why I really strongly argue that everybody has their own pair of binoculars for totality. Don't share. Even a cheap pair of binoculars is better than sharing binoculars, okay? So you only need one pair of binoculars with filters because you can share that because the partial takes a long time. But for totality, everybody should have their own binoculars already on a strap around their neck, ready to go. Okay. So the fast solar winds comes from these polar plumes at the north and south poles, and the slower part of the solar wind comes from the closed magnetic field line regions. So you can almost see the magnetic field lines on the sun, even though you're really not seeing the magnetic fields. What you're seeing is the electrons trapped on those magnetic fields scattering sunlight. All right, so this will now be a close-up of what you'll see as you go into totality.
As the moon covers the last bit of the sun, the sky around you gets dark. It's still not safe to remove your solar filters, though. The last piece of the sun makes a diamond ring. Bailey's beads appear, small bits of the sun peeking through valleys on the edge of the moon. Now it's safe.
And now you see the prominences as these red loops. Now this is an animation, but there's some real photographs I'll show you which show very similar to this. I need to get... All right, and here is how the moon shadow might appear as if you were from the lunar
This sequence shows how a solar eclipse might appear from the lunar surface. Night is falling on the moon. The distant mountains are still in sunlight. After sunset, the lunar surface is blue, lit by Earth shine. It's new moon at Earth, but it's full Earth at the moon. Since the moon's shadow covers only a small part of Earth, the lunar surface doesn't get a lot darker.
And now this is an actual image of what the Earth's shadow looks like from space. And this is one from the Discover satellite that was at L1 for the 2017 eclipse.
This shows how the moon's shadow might appear from a spacecraft in Earth orbit. This sequence is based on actual previous space-based photography. The moon's shadow isn't just a sharp dark spot, but has shading as the penumbra darkens to the umbra at the center. Since the spacecraft is in the penumbra, the sun is only partially covered by the moon.
And you notice it's elliptical because it's a round shadow on a spherical surface.
A lunar eclipse as seen from Earth is leisurely, taking 3 hours or more. When the moon enters the umbra, a dark whiteout appears and grows, the partial phase. When the moon is entirely inside the umbra, totality begins and can last for an hour or more. The moon appears red because the only light reaching it is refracted through Earth's atmosphere. One side might be brighter than the other because it is closer to the edge of the umbra. When part of the moon emerges from the umbra, totality is over. When all of the moon emerges, it's the end of the eclipse.
Now, what would you see if you were on the moon during a lunar eclipse?
In a lunar eclipse, the moon travels through the Earth's shadow. If you were on the moon, it would be a total solar eclipse for you. But the Earth appears 4 times as big as the sun. The land around you gets dark. When you are completely in Earth's shadow, the land around you is red. The only light that reaches you is red light bent by Earth's atmosphere.
So you notice you only see the corona on one side going in, and then at the end of it, you'll see the corona only on the other side coming out, because the Earth is just so much bigger than the sun. Okay, so take away, if you possibly can, go to totality. You may have trouble finding hotel rooms in totality now. So what you do is you find a hotel at about an hour's drive away from totality. And that's a doable thing, because it's early afternoon in Texas. So it's, you could leave at 6 o'clock and have plenty of time to get someplace by 9 and be set up. If you want to drive your whole school, I'd leave at 4 or 5 in the morning, because it's going to be tremendous traffic. Okay. And some of the hotels don't start taking reservations to a year in advance. So if you want to make a trip, what I would recommend is you make a reservation, not the night before, but the night before that, because that will open up earlier. Okay, so do a 3-day reservation starting on Friday, and you'll beat out all the guys who waited till Sunday to make a reservation starting Sunday night. The worst thing has happened is you throw away 2 nights of your reservation, but you've got a place for totality, which might be a problem. The other thing is to look at is the weather. Okay, so this is the statistics, and like a lot of statistics, what actually happens is not what you're necessarily expecting. But if you were in Mexico, the probability of cloud cover is about 25%. So you got like a 75% chance of good seeing in Mexico, and probably a 75% chance of being mugged. But when you come into the Texas border, you see it's jumped up to about 50%. So it's around 50% to 55% cloud covers. So 50-50, you'll see the totality in Texas. But you notice as you go further, take a picture of the shadow. And this is one that my kids did and took a picture of it on their leg. But same idea, punched it in a cardboard and then took a picture of it. And this is something you could do at your school. You could have an overhang, one of those 10 by 10 things with an overhang, punch some school things that people can come perfectly safe. They're under the overhang and they can see those little pinholes on the ground. That if you really have a school that is hard over, that they doesn't trust them to put on eclipse glasses, that's something you can do. Straw hats are fun to do. And I've even seen some people punch holes in the caps of baseball caps, and they'd have little eclipses on their face. Those are just fun things to do. A colander works really well. Eclipse shades are great, but they don't have any magnification. So you get a little teeny, eclipse, which is okay. But one of the things you can then, I really strongly recommend is putting a eclipse shades on front of a pair of binoculars. And so, Jimmy, would you bring those to me for a second? So, let's stop share for a second. All right. So this is a pair of binoculars. Thank you. This is a pair of binoculars on a tripod. Okay. And I want to really encourage doing something like this with your class. Okay. The nice thing about having a pair of binoculars on a tripod is that once you've got it aligned and looking at the sun, then people can just come up and look through the binoculars. Now, these are the eclipse shades that I recommend. They're from Rainbow Symphony. They're $20 a piece. Last eclipse, they were only 15. But they pop on. You get them in different sizes. So you pop them on to your binoculars. And so now you have an eclipse filter on the front of your binoculars. And so that once you've set this up and are looking at the sun, then you can leave it and have the kids, if they're short, have a little step stool that they can step on. Now, the only tricky thing about this, for this eclipse, it's going to be pretty high in the sky. And the height in the sky depends on your location, but it's, for here, I think it's like 60 degrees. Okay. All right. And not all tripods will let you go that high. So practice ahead of time. This one will, okay? But you want to have the legs extended so that you can get up underneath it, because otherwise you crick your neck, okay? So there are little things called astronomer's chairs, which are little stools, and you can lift the seat up and down, or you just make sure you have we haven't extended the last legs of this thing. So this one actually goes much higher. So ideally, you'd like to have a binoculars that can get as high as your eyes. So then you don't crick your neck, okay? So looking at it through the binoculars, you want to have your tripod high and have it go up to 60 degrees. Now, if you handheld them, the problem is it's hard to see anything but the sun when it's handheld, so it's hard to find the sun. Now, if you don't have and the nice thing about these is when you go into totality, then you can just pop them off. Now, if you don't have those, then one of the things you can do is take your eclipse glasses and cut them apart. And you tape over all the cardboard so that nothing is visible except that lens, okay? So there's no stray light. Now, I use gaffer tape, okay? Gaffer tape kind of looks a little bit like duct tape, but it has a really important feature, which is that it doesn't leave gum and gooey on your tripods when you take it back off. It's completely opaque, but it doesn't stay. And that's why gaffers use it when they're making movies, to tape down cables so that the actors don't trip over the sound cables. And then they can pill it back up and they haven't ruined the floor or the carpet or whatnot. So anyway, it's about $10 a roll. You can get it from Amazon. Really recommend it. Now, there's one key thing you need if you're going to put binoculars on a tripod, and it's this device here. And this is called a binocular tripod adapter. Okay, now this one's from Pentax and it's more expensive. And you notice I can then just put the quick release from the tripod on it and then pop it on. And then on your binoculars, most good binoculars have a screw hole, which is standard thread. It's a standard tripod thread. Okay, so I can take this tripod adapter, screw it into my binoculars here. Okay. So I can do left-handed. Okay. And now I can put that on my quick release on my binoculars. And I need to tighten it up so it doesn't rock and roll, but that's how we do it. So this piece you can get from, there's a cheap one on Amazon for $15. Or the Pentaxes are a little more expensive, but anything will work. But that and a cheap pair of eclipse glasses can make you a nice pair of filtered binoculars. And what's important is, because the partial phases are so long, you can really have one pair of binoculars that you can share with 30 people. They can go by and just take a look, okay? Because it's an hour of partial phase. But once it goes total and you only have 3 or 4 minutes, then everybody has their unfiltered binoculars already on their neck, ready to go. Now, if you don't trust your kids, if they're too young, then don't let them have the unfiltered binoculars. Then, don't pass them out till later. But what we typically do is to have a big whistle, and when you blow the whistle, that's when they can take the binoculars and look at the sun. They don't have to be expensive binoculars. They can be 3x, 5x for the kids. Now, for me, I like a decent pair. This one goes from 8 power to 22 power, and so it's really nice. You can zoom in on it nicely, but for the individual students in your class or your young children, a $20 pair of binoculars is just fine. Guarantee they will get a great view. All right, back to the sharing here. Okay. So now the problem is, once you've got those filters on your binoculars, you can't see anything but the sun. So it's hard to get them in line. And when they're on a tripod, you can look at the shadow and make the shadow small. But if you're handheld, what I found works is I close my eyes and I look at the sun and I feel it warm on my face, and I move my head around and neck around so that it feels like I'm, it's right, staring right at it. Then bring up the binoculars and then open my eyes. Okay. And if you've got them zoomed out, so you have a wide field of view, then you can often find that sun. Okay. And then you zoom in to have a higher focus. Now, what I have found, sometimes if I've got a friend and they're trying to find the sun with the binoculars, I'll look at the shadow on their face, and I can help them. Oh, you need to tip up, or you need to tip left, or something like that. But yeah, looking straight up through binoculars is really hard on your neck. So having a lounge chair is really going to be helpful for these eclipses. Here's, looking through a pair of binoculars, but this is more like 40 degrees. And so I'm sitting on a little stool. But for this one, it's going to be tipped up even more. Now, another thing to be really careful of is you've got to have the filter on the front of the binoculars and not at the eyepiece. So this guy wore a pair of binoculars and put his glasses on his face. And guess what? The light through that binoculars burned a hole in his eclipse glasses. So you can imagine what it would have done to his retina. So beware. You want to stop the light the farthest out you can. Okay, so the solar filters, $20 each lens, and the adapter about $15. And that's how I show you. Now, another fun thing you can do is what's called binocular projection. So you put the binoculars on a tripod, but now without the filter, okay? And you align it by making the shadow the smallest. You notice how that shadow, you just look at those two holes, that makes the shadow when the shadow is the smallest, then you know it's looking directly in the sun. And then I tip it just a tiny bit so the image goes into a shaded area. And now you can get a really nice image of the sun. But you do have to be careful that kids can't go up in front and try to look through this binoculars. So whenever I do a binocular projection, I put the tripod as low as possible so that nobody can, they have to be doing a low crawl in order to look through it, because that is something you will really want to watch out for. And so like here, I've got it almost all the way down. You can see the image of the sun here in the shadow. And And so I take a piece of black fabric and wind it around there, leaving the open end of the binoculars open. And now I've got this nice shadow around it. And so you can see the image. And again, you can have this here, and a lot of kids can go by. And for an hour or two, it doesn't really hurt your binoculars, but you don't want to put a 5,000. Now I've used my very best comet catching binoculars this way, and I've never hurt them. Another thing you can often do is take a cheap telescope and do the very same thing. Make the shadow the smallest, and there's the image. Okay. Then once you get the image, wrap a towel around it, and then you got the image in a shadow. And again, you have to be sure the kids don't look through that. Now, what I recommend for schools, because unlike the binocular projector and the telescope projection, which can be dangerous if you're not careful, this is a really completely safe way to view the sun. It's called the Sun Spotter. It's about $400. It's from what was the name of it? Science First. Science First. And what it uses, it has a lens here and a mirror and another mirror, and the image comes there. And so it's never a small focus. You never have a small image of the sun that can burn anybody. And it makes a good size image. It's like 4 inches across. And you rotate it, so that this pin here, you move it around and up and down so that this pin has no shadow. Okay, you notice that? When this pin has no shadow, then you've got it roughly aligned. And then they'll turn out to be a little dot of sunlight inside this white ring. And when it's close, you can see it's not perfectly aligned, but when that white dot is in that ring, then you're going to see your image. So it really gives you a way of aligning it and not even have to look at the sun to align it, which again is a safety feature. The other thing that I really like about it is it can work pointing straight up. And here in Houston, when we're observing the sun near the summer solstice, the sun is within 6 degrees of being straight up. And yet it still makes a really good image. And if there are sunspots, the kids can sketch them. And so again, I really recommend. It's an investment, but it's one that is not just for a total eclipse. You can use it anytime you want to see the sun. And let me just stop share and show you the one I've got here. And literally I've had this one for 10 years, and every equinox and every solstice we have an event at the Museum of Natural Science. So it's perfectly safe, makes a nice image here. You have to unscrew it to carry it, and then you can just change for the altitude of the sun by tipping and change the azimuth of the sun by rotating until you get the shadow of this pin to go away. And so it's easy to align, completely and utterly safe. And if you want your PTA to spend $400, then again, you can run 30 people by it easily, in 30 minutes. You could have a camera on it so that other people, that were not in there could watch it. So really strongly recommend this as a safe way. Interestingly, the patent on that ran out this year. So yes, you could, I know you could make your own now. And in fact, if you look up the patent, it actually has pretty detailed instructions. But the alignments of those mirrors are pretty tricky, and getting the right lens is pretty tricky. And, I don't think I would do it for more personally, but you could. All right, so back to the PowerPoint. Okay. So we're almost there. Another solar telescope that you can use is called an H alpha. Instead of reducing the total sunlight, it reduces the spectral amount of the sun. So you're only looking at one red line emission, which is the hydrogen line on the surface of the sun. So you can see the granulation on the sun's surface, and you can see the prominences before the totality happens. So here I am demonstrating some of these. So this is looking through the telescope, through the binoculars. You notice the tripod is high. Oops, go back. And here's the projection. The tripod is low. Okay. And here's a sun spotter. All right, so here's some activities: punching the holes for the pinhole pictures, measuring the temperature changes, using the sun spotter to make sketches of the sun as it goes and any sunspots that are visible. You can put a filtered camcorder on a TV. Oops. You can have a reading chart to see which of the smallest fonts you can read. You can photograph the little eclipses under the trees. You can monitor animal behavior. Another fun thing is to use ultraviolet beads. Make a necklace of ultraviolet sensitive beads, which are beautifully colorful when the sun's on them, but as the sun goes on, they become clear. So here's like a data sheet, and there's one of these is in that same folder. So you can put in the time and the temperature and the cloud cover and wind speed if you can estimate it. Now there is a software app that's coming from the Globe Observer, and it'll be called Globe Observer Eclipses, and it uses your smartphone to measure the light level. Okay, it's not out yet. I keep hoping that it's going to be out so we can practice with it. Here's another data sheet that's in the same folder. What kind of animal or birds have you heard? Are you hearing roosting behavior? Are the dogs lying down? Anything that you note, you can put on here. Now, in Texas, for example, the annular eclipse goes over SeaWorld, Texas, and over the Texas State Aquarium in Corpus. Now, the totality also goes over SeaWorld and other zoos around the state. So on our website, texaseclipse.net, we have all the parks listed. And a lot of the parks, you cannot get a reservation to 6 months in advance. So again, be ready to pull triggers if you want to try to go to a park. Try reserving a few days ahead for a week. Don't wait till the last day and send a contingency to park in your campsite. Okay, so what can you do if it's cloudy? And 50% chance or worse that it's going to be cloudy. But I can tell you, even if it's cloudy, you will still be in the shadow of the moon. So the temperature will still fall. The wind still will change. The birds will still roost. You can still use the reading chart. You can still use the UV beads. You can watch it on NASA TV. There's going to be a number of live feeds from around the country, and at least some of them are going to be, we hope, not in the clouds. But basically, don't give up, because the clouds can become more transparent, and just still let your body experience it. Now, there's a lot of cool citizen science that you can do. the one I just mentioned, the Citizen Kate, where we're getting identical telescopes across the United States. If anybody's interested in being a location for that, let me know, because I'm going to be the regional coordinator for Texas, Oklahoma, and Arkansas. The Globe Observer Eclipse app that I said is not yet posted, but they promise it's coming. One fun thing to do is to take a pair of not eclipse glasses, but diffraction glasses, and put them in front of your camera and get a spectrum of the sun. And you can see the hydrogen lines. That's why H alpha, we use H alpha to look at the sun, that's one of the brightest lines in the solar spectrum. But there's also H beta in the blue and sodium in the yellow. So that's a fun thing to do, is to take a picture of the spectrum. Another cool thing that some non-scientists did was to take an image of the sun in this green line, okay, and also in this red line, okay. So this is 9 times ionized helium, and this is 13 times not iron, I said helium, 13 times ionized iron and 9 times ionized iron. And as you can imagine, the more ionization, the hotter that part of the corona is, because more heat means more ionization. So by combining the green with the red, then you can map how hot the corona is, which is kind of cool, by just superimposing two images of the sun. Now, these kind of high resolution aurora coronal pictures are done by a guy named Miloslav Druckmüller, who is the coolest guy. He went with us on our Antarctic trip, which unfortunately was clouded out. But he has this wonderful mathematical technique to basically trace the field lines. And so he aligns multiple exposure images, but uses the field lines to do the tracing, which is really, really cool. Another fun project, which is done with ham radio operators, is to watch the returns from the ionosphere. And when you have a lot of ionospheric bouncing, then you know the ionosphere is dense. But when the moon shadow hits the ionosphere, a lot of the ionosphere recombines, and so it becomes less of a reflector of radio waves. And they're going to have what they call an eclipse QSO party this time, and see how they're when you're having a conversation with somebody, when exactly do you lose that contact? And they can map that out, which is a lot of fun. Okay, so when's the next one? Well, again, there's roughly 2 solar eclipses every year, but some might be partial. There's roughly 2 or 3 lunar eclipses each year. Again, some may be partial. At least a partial lunar eclipse 2 weeks before or 2 weeks after a total. And then after these 2, the next one through Texas, it's a total in 2045, which just barely touches the panhandle. So here's this eclipse that we're coming up on in just over a year, but here's the 2045. So it's kind of similar to the 2017. Here's the 2017, right? But it's a little further south, and it's also a little larger, which means it's going to be a little longer. So the moon's going to be a little bigger compared to the size of the sun. So these are the total ones coming up, and these are the annulars coming up. So here's the 2023 annular, and here's another one coming in 2048 for those of us who are still going to be alive then. Here's one that's going to hit Cuba and Haiti in 2038. So, be aware, there are some coming, but most of the time, if you want to go to an eclipse, you've got to go somewhere else. And so some of us who are serious eclipse junkies do a lot of that. Okay, Photography, it's hard to do a perfect shot. You really need to have a range of exposures. You've got to be sure you can turn off the flash. You want to have short exposures to get the prominences and the inner chromosphere, and long exposures get the corona, but overexpose the prominences. So when you see these beautiful pictures like I'm showing you, those have all been processed. But your eyes can see it. That's the amazing thing, is your eyes can automatically do that compensation. So practice for totality with the full moon, but make sure you don't overexpose, because that's really easy with, especially with dumb cameras, that they'll overexpose. And then for the partials, practice with the sun and a solar filter. So you have plenty of time to practice. Videography, again, it's really important if you can adjust the exposure. It's on a video camera, it's called Iris. And both of your hand cameras and the video cameras, be sure you can set it to focus at infinity. If you've got a dumb regular camera, you can set it on sunrise sunset mode, because that deliberately underexposes, and it also gives you focus at infinity, I've discovered. With a smartphone, you zoom in to the moon, or, for practice, and then there'll be a little slider, exposure slider. You can slide it up and down so that you don't overexpose too much. But a video camera, if it's got an LCD viewfinding panel rather than a through the lens viewfinder, then you can actually take off your filter a little early, so you can catch the diamond ring. But again, not if you've got, only if you've got a LCD type viewfinder, as opposed to a through side-by-side viewfinder. But ideally, have at least one video camera or somebody's smartphone set up on, to record you and your group's reactions and your oohs and ahs, and a widescreen view of the surroundings, because that's really what the smartphones can do well, and so you might as well make use of that. All right, so like I said, this is a digital combination, but it really does give you some of the details that's similar to what you'd see with binoculars. So that's 2006. That's a wider view of the 2006 one. I think this is the 2010 one. All right, so we have a tic-tac-toe player that you can download. It runs offline. And the player is free, but the editor has a 30-day free trial. So that you do offline, but we have exported, and like it, you play one against each other. And so if you get it right, you get the square, and the other person, if you get it wrong, the other person gets the square unless it gives them the game. And so that's always fun. Now, I have taken some of those questions and put them into the online game that we played just before. I do want to encourage everybody to join our Eclipse newsletter. We'll be sending out lots more material as time comes by. And at our Eclipse website, we have tons of material, including links to this PowerPoint and to other activities. So here's where I get most of my solar filters. But if you want high quality ones for cameras, then you can go through any of the online photo stores. In Houston, we're lucky to have a really good astronomy store called Land, Sea, and Sky, which is very close by. And so here are some of my equipment recommendations. I have printed out an equipment recommendation sheet in that folders, the materials folder for this talk. So, and also on that website, I have a bunch of links of additional sources of material. Okay, so let's do one more Kahoot. All right.